graph a log. Please make sure you're paying attention. As long as you guys are paying attention, this lesson will not take me very long to get through, and you will have plenty of time to work. Okay? So first, I want to figure out the relationship between logs and exponentials. And to do that, we are going to compare the graphs of each. So y equals 2 to the x. We've graphed that plenty of times. When we graphed those, we did a t-chart and we plugged in 3 points. What were they?
0, 1, negative 1.
And we put those in for the exponent. So 2 to the negative 1 was 1/2. 2 to the 0 was 1. And 2 to the first is 2. So when we plotted that, 1, 1/2, 0, 1, 1, 2. Focus. All right. When I graph this, what does it have on the x-axis? Yes. This is a horizontal asymptote on the x-axis. If I ask, what is the domain of that? What is the range? So that we have done before. So now let's talk about the log. We know that when you have a log, you can change it to exponential form. So in exponential form, this would be 2 to the y equals x. So it's graphing another exponential. When we graph exponentials, we plugged in -1, 0, and 1. But when I put those in, I put them in for the exponent. Which variable is the exponent now? Okay, so I'm going to plug in -1, 0, and 1 for my y values. So 2 to the -1, 2 to the 0, and 2 to the first is 2. So if I plot these points, 1/2, -1, 1, 0, 2, 1. And this is going to get closer and closer, but we know we can't plug in a negative. We've already talked about how with logs the arguments always have to be positive. So this ends up with a vertical asymptote at 0. What's the domain of that log function I just graphed? What is the range of that? So what is the relationship between these? If you look, all of your ordered pairs, all you did was flip x and y. The domain of the first one was the range of the second one. The range of the first is the domain of the second. These are inverses of one another. They're complete opposites, they undo each other. So as far as graphing, it's very, very similar to graphing the exponentials. Okay, we'll take our log, we'll write it in exponential form. The difference is the -1, 0, and 1 are going to be going in for the y. Exponentials have a horizontal asymptote. Logs have a vertical asymptote when we graph those. Any questions there? So let's take a look at this one. I have 3 things that I'm going to graph. The first one is just my parent function, and then I'm going to do a couple variations of that parent function. So what would this be? Y equals log base 1/3 of x. What is that in exponential form?
1/3 x, or 1/3 y equals x.
Good. So when you make your t-chart, -1, 0, and 1 are your y values. What is 1/3 to the -1? 3. 1/3 to the 0, and 1/3 to the first. 3, -1, and 0, and 1/3. going to draw this dash because it's my parent function here. So it has a vertical asymptote of the y-axis right now. Everybody okay with that one? So then B. What will this minus 2 do? When you move left or right, what happens with that? So we will move our asymptote to the right 2. Just like with exponentials, when we moved up or down, it moved that asymptote because it was a horizontal. Logs have a vertical asymptote, so that will move when you go left or right. And then you can just move each point to the right 2. Last one. What would this one do? When you go up, will this asymptote move? No, it's taking that original black dashed line and moving each of them up 1. So you graph your parent function and then all the same transformations that we have been doing. Is that one okay? I would like for you guys to try one. So I want you to graph the parent function, which would just be your regular y equals 1 raised to the x, and then do your transformation.
writing that one as a parent function, right?
Not quite. The negative is on the x. So if you change the signs on your x, it flips it over to the y axis.
Whoopsies.
And if we can,
Look at you being nice today.
add to,
But I think you didn't walk over here with that, and you didn't turn back around to get us, so.
I think I'm moving right.
Alright, so the parent function, this would be 5 to the y equals x. So y is your exponent, so we'll plug in the -1, 0, and 1. 5 to the -1, so negative exponent just flips it, that's 1/5. 5 to the 0, anything to the 0 power is 1. And 5 to the first is just 5. So if we plot these, we have 1/5, -1, 1, 0, and 5, 1. Here's our parent function. Where's your asymptote? Yep, just on the y-axis. Okay, a negative on your x. That's saying it's making the opposite of all of your x's. What that does is reflects it over the y-axis. Final graph should look like this. Questions on that one? Do we need some more transformation problems? The last thing I want to talk about today is the domain. So if you have a graph, you can find the domain from it. What is the domain of this one?
negative infinity to 0.
Right. And the reason, if you just look at the equation, we talked about how the argument has to be positive. So that means this negative x has to be greater than 0. And if you divide by a -1, what happens to your inequality? It flips, so it has to be less than 0, the negative infinity to 0. So we can get the domain by either looking at the graph or just from the equation itself. So let's practice that, and then we are done. So if I'm looking at this first one, when I'm asking about the domain, I don't care anything about the base. I don't care if there's a negative in front of my log or something added on the end. All we care about is the argument, the thing you're doing the log of.
Negative infinity to 1. Right?
Whatever is in there has to be greater than 0. So if you add your 1 over, x is greater than 1. So it's starting at 1 and everything larger than that, so it would be 1 to infinity. It can't equal 0, so the 1 gets a parenthesis, not a bracket. B. What is my argument on this one? X. The only thing you're doing the log of is x. So I don't care about anything else, just that x, which has to be greater than 0. Just be 0 to infinity.
Negative infinity to -4. Right?
Negative infinity.
Gosh, so stupid.
No, you're just trying to look at it. So this one, the argument, -x plus 4, greater than 0. You subtract your 4 over, so -x is greater than -4. Divide by -1, so that flips, so you get x is less than 4. So my interval notation would be negative infinity, positive 4. All right, the last one is maybe a little bit trickier. my argument, x squared minus 4.
Negative 3, negative 2. 2 equals
How'd you get it?
difference to quarters.
Okay, so that factors into x plus 2, x minus 2. So if you think about the graph, that means it hits the x-axis if you set each of these equal to 0 at negative 2 and positive 2. Okay, we know x squared is a parabola, right? If it's a positive x squared, then that parabola is opening
Upwards.
upwards. So I want to know when it's greater than 0 or above the axis. So you could look at that graph and you could say, well, it's above the axis here and here. So from negative infinity to negative 2 and from 2 to positive infinity. Anything you have questions over or want extra practice on? Okay, so here's the game plan. There is a handout posted on Classroom. You have a lot of time today, so if you didn't get that Math Excel done, you have some time to work on that as well. Tomorrow we are just reviewing these two sections, and then we'll probably do a quiz on Friday. So if you're going to be gone Friday, we need to come up with a plan there.